to. Okay, so the tests for the delivery are going to be the most fascinating ones because over there we have like, this console driven application. It's an interactive one. It kind of hangs there. It waits for our input. So we're going to fake the console in such a way that we're going to give it a list of all inputs. And then every time it's going to ask the user for the input, it's just going to keep like taking from this list. Okay, so let's go to the ControllerSuite. Okay, and ControllerSuite. Okay, by the way, this is the location. Okay, close this one, extends test suite, test hello world. Okay, I will start like this. One should be one like this so that I see that I'm running, I'm running the appropriate thing. Let me open the controller, which is going to be, I believe, this one. Okay, yes, this one. Okay, now the first thing that we're going to see in the controller is that it needs a bunch of dependencies. Okay, so we're going to start by doing the same trick. We're going to say import ControllerSuite, and we're going to have an object ControllerSuite like this, object ControllerSuite like this. All right, let me create a little bit more space. Okay, so one of the first things that we need to do is we need to have some pattern for the datetime formatter, and it is in Java time format. Okay, so this one we're going to not fake. We're just going to simply grab it. We're going to say import Java time. I already forgot what it was. Java time format. Format dot datetime formatter dot ISO local datetime. Okay, so we're just gonna grab this one and we're gonna rename it to pattern like this. Okay, so we're simply grabbing it, and this is going to be our pattern. Okay, if you remember, we have two of these patterns. One of them is to put some dates in, and the other one is going to be just for displaying them, right? And this is the one for displaying them, and we don't really care. So I'm just gonna grab this one. Okay, the next one that we need to fake is going to be the boundary. Well, obviously. So let's go over here, and we're going to say private class fake boundary. By the way, many teams, they don't even abstract over the boundary. Okay, so this is the boundary, right? It has like, same as always, it has a trait and it has the interpreter, right? So this is the DSL, this is the interpreter. And many teams, for the business logic of the application, they don't even have this trait. And they don't do this because, they basically say that you would never fake business logic, right? You never want to not test the business logic. I disagree. I believe in this particular case, actually, I don't care about the business logic, right? So I just want to see that the controller, it would, print out the proper things, like if I want to say something like, I want to fake the boundary and say, hey, if the boundary, returns and then either, the left side, then you should display it in red, things like this. Okay, so I don't really care about the logic over here. I already tested the logic somewhere else. We obviously could still have integration tests, but we're not going to write any integration tests today. Not because it's hard, just because even writing these couple of tests is already taking way too much time. All right, so we're going to have this implement all members. Okay, let's see, empty line over here. I really don't like empty lines, the unnecessary ones. Okay, over here, here, and here, and here. Okay, a bit of OCD about empty lines. All right, the next one is going to be the fake console, and it's always the same. Fake fancy console of F, right? I never override things over here. I only override them in my test. Okay, so extends fancy console of some F. Okay, and that's all I need. Now Metals is going to generate the good stuff for me. Okay, over here, and let me mark all the overrides, go down one like this, remove the empty line. Okay, this is the fake fancy console. The next one is going to be, where is it? This is the boundary. The random. Okay, so in many cases you could actually use the real thing, but for this one we're just going to over engineer it, and we're even going to fake the random one. Okay, just so that I can show you how easy it is to just simply fake everything. Okay, so we're going to say fake random for some F. Okay, it extends random, random F. Okay, I'm going to say well, I'm not going to do this manually. I'm going to ask Metals to do this for me. Okay, like this. Okay, so they're all like sort of like completely, complete dummies. Okay, now I'm actually going to have a couple of useful ones, and like usually, like as you have seen, like for example in the boundary suite, Okay, I'm only like overriding like the parts that I need inside of the test. In this particular case, I know that I will reuse a couple of things, like for example the random generator and also this fake fancy console, and so I'm going to have them over here as well. Okay, so the first one is going to be, let's go and import cans. Import cans. Okay, so this is going to be the useful random one, and again, like in a real application, I probably would not fake the random one. I would just use the real one. But over here, I just want to show you how easy it is. Okay, so we're going to have f, and it's going to be an implicative. Okay, and we're going to give it some fake n, right? Okay, and I'm going to say extends fake random of f, and now metals is going to generate some stuff for me. All right. Oh yeah, so in this particular case, I need to be specific. Override next int like this, like that. And so what we're going to do over here is we're going to simply ignore the parameter, and we're going to always return this one. Okay, so we're just going to say f pure fake n. Okay. Again, in this particular case, we're not going to use this one. I mean, we're going to use the class, but we're not going to inject anything that we really care about. We're not going to test this. I just wanted to show you how really easy it is to fake everything, right? Because Tagless Final forces us, well, not forces us, but encourages us to code against interfaces. And so it's super easy to write tests. Now, the useful console is going to be probably the jewel of this video because it's going to be the most fascinating one, the most exciting one, actually. You know, so the way we're going to do is we're going to give it some state. You know, we're going to use a ref. You know, for this one is a little bit bigger, so we're not going to use vars like we did in the in-memory entity gates in the boundary suite where we wanted to determine if the method was called simply by having this var. In this particular case, we're going to have 3 vars, and this is already big enough to to get out the big guns like the ref. So what we're going to do is we're going to have a companion object for the useful console, the one that we don't even have yet. And inside of it, we're going to have a final case class with some state. And by the way, some people use the state monad instead of the ref. The benefits of the ref is that you can write concurrent tests and everything will still fine. The state monad cannot model concurrency. Okay, so what we're going to do is we're going to have some input, right? So every time the controller is going to ask for the input of the user, it's simply going to read from this list. Okay, and then all the regular, all the normal output is going to put over here. Vector dot empty. Okay, and all the errors is going to put over here, vector string, vector dot empty. Okay, in fact, for the console version, we even have warnings, but in this particular video, we don't really care about the warnings. Okay, so now we're going to have the private class useful console f, and for this one, we're going to need the effect sync, and it's going to get the ref of f, where's the useful console dot state. Okay, and this thing is going to extends fake fancy console of f like this. Let's import the ref. Metals is going to do this for us. Let's go and see it's actually in the proper place. All right, cool. So in this particular one, I already know which methods will be called because I prepared for this video. And so I'm going to simply go and override them now. I believe it's going to make sure that the viewing experience is going to be a little bit better. So the first one that we're going to override is going to be get this one. Okay, so this is the one that asks the user for the input. It has this obscure long name. Okay, so every time the user is asked for the input, all we're going to do is we're going to say ref.modify. Okay, and we have our state. Okay, whoops, like this. Okay, so all we're going to do is we're going to pattern match head tail on state.input. Okay, so this this input list. Okay, so we're just going to get one of them. Okay, and then we're going to say state copy input is going to be tail and head over here. All right, so if you remember, modify actually wants you to produce a tuple, right? Was the next state, and you kind of sort of have like a mapping over here, right? So this is going to be the next state, right? So the input is going to have like one less of the elements, and this is the actual input, right? And this is going to throw an exception if we have a bug in our test. But if our tests are going to be fine, it will stop asking for the input, and this method will not throw. Okay. The next one that we need to override is going to be override put string line. Okay, it's going to be this one. Okay, so this is basically the output to the regular regular stream. Okay, we're gonna say ref update. I'm gonna have a state over here. I'm gonna say state. Whoops, I was press Control Enter. I'm gonna say state copy. Output is going to be state output. Please append the line. Okay, so this is exactly the reason why I used vectors over here, because I want to append to the output stream and to the error stream, and for the input I just need this fast decomposition of the list, and therefore I just went for the list. But I'll be honest, these tests, they will have like 2 or 3 lines, so it really doesn't matter which data structures you use. Okay, so the next one that we're going to override is going to be success. Okay, and the real implementation of the put success, remember that this is the fancy console, this is the one that adds the colors. So the real implementation would add the green. Okay, in this particular case we really don't care, we don't want to deal with the stuff, so we're just simply going to call put string line with the line. Okay, like this. Okay, and the last one that we're going to do is, I'm actually going to copy this one. This is going to be in the error line. Okay, and all I'm going to do is I'm going to do errors over here. Okay, this is all we need to do, state errors. Okay, like this. There we go. Okay, so put errors, simply going to append to the errors vector. The regular output is going to append to the regular vector, and the input is just simply going to read from this list. Okay. So the next thing we need to do is we need to pick our effect, and in this particular case we have effect IO actually. By the way, this is one of the things that I forgot to mention over here in the boundary suite. We're in the core, right? We're in the core of our application over here, and the core doesn't even have a dependency on cat's effect. We could add it, and if we didn't like it, we could simply add it at least on the test scope. But if ID was enough, then why not use it? Okay, and if we had something like applicative error or monad error, then we could use something like either. We don't need IO. Okay, some people don't like this. Some people really say, we should always test, with the effect type that you're going to use in production. Now, as a reminder, we still haven't written even one useful test, and we're not going to start now. The first thing that we're going to do is we're going to create a helper that will do like all of these asserts for us. And it's going to get some to-do ID. It's going to get like a bunch of things that it needs. First of all, it's going to get some boundary f to-do ID. Okay. Then it's going to get the input, which is going to be a list of string. Okay. Then it's going to get the expected output, which is going to be a vector of string. Okay. And then it's going to get the expected errors, which might be empty, vector string. So we're going to do this one just for the ease of use. Okay. Now in the controller, if you remember, and the controller has no idea what the to-do ID is, and so it needs some helper that would explain how to parse a string into this to-do ID. Okay, so we need to have it over here as well. Okay, and inside of it, it's going to produce an assertion. Okay, so inside of it, we're going to have a program, which is going to be a program f of assertion. Okay, and let's do this for now, and in the end, we're simply going to run the program. Okay, program unsafe run sync, like this. All right, so this is a string. It did not find f because I did not choose the effect type, so we're going to say not the import, we're going to say private. Well, actually we can steal this from the in-memory entity gateway suite, which is these 2 lines. Okay, just like this. Okay, so this is our f. Okay, great. So our program is going to be very simple. It's always going to be the same program. We're gonna give some input and we're gonna expect some output. Okay, so the first thing that we're gonna do is we're going to produce the ref of f and the useful console state, and I'm gonna say that this is going to be useful console state. And this is the interesting part, right? So we're simply going to give it the input. However, remember our application, it always wants, the next input. So it will wait forever. So what we're going to make sure is that whatever input we're giving, that it will always append the queue. Remember, if we type in queue, the application would stop. So we're going to simply always do queue. Okay, and this way our test will always like sort of finish. Okay, so now we're going to create the controller. Let me create more space. Okay, and notice that this is an equal sign over here. So we're going to say controller.dsl for f and to do ID. Okay, and we're going to give it the pattern, the one that comes from over here. Okay, let's go back. We're going to give it the boundary, whatever was inserted over here. Then we're going to give it the new useful console was this ref over here. Okay, Now we're going to give it the new useful random, which is going to have the fake n of 5, but again, we really don't care. I probably should have used the real one anyway, even for this video, but now it's too late. Okay, so now we're going to get the program out, right? So this is the one that returns the unit. Okay, and then before finishing, we're going to get the data out of the ref. Okay, and then we're going to write our assertion. Okay, I'm going to say that the data output should be whatever was expected output, which is the parameter over here, expected output, just a vector of string. But let's not forget that we appended the queue, and so we need to also expect until next time, right? This is what our application does at the end. Okay, so we're going to expect the output, and we're also going to expect the errors. Errors should be expected errors. By the way, this is one of those things that you might input like, I don't know, 10 different commands, right? So create a to do, and then update description, and then delete the to do or something, right? So you might accumulate a bunch of errors and a bunch of outputs, and so you can have both of them. Cool. So now that we have all the scaffolding, we can actually go and write our test. So as of right now, we have hello world. The simplest test that we can write is the one that will simply make sure that our test always that the queue is appended. Okay, so we're going to say TestSuite should quit automatically. Okay, so all we're going to do is we're going to construct a boundary. I'm going to say boundary of f and unit. I'm going to say new fake boundary of f and unit, because we still don't care about the ID. Okay, right. And by the way, this is the reason that not the reason, but the fact that we have a fake boundary also allows us to write all of these tests that we're writing right now, even before we have the business logic. Okay, as soon as the tray is there, we can do it. Okay, so now we can call assert, which is going to give it the boundary. We're going to say that input is going to be listed empty, because remember, it will always just append the queue. Okay, and expected output is going to be vector dot empty, right? Because the expected output will always have until next time, and we don't expect any errors, and this is why we have this default parameter. Okay, so this is almost everything that we need. The only thing that we need is the implicit view from string to unit. If you remember, inside of this parse thing, we have a companion object which knows how to parse a string to UID, and also how to parse a string into an int. So now all we need to do is we need to go over here, and we need to add it somewhere. And this is again like one of those things that will probably need to be shared between many tests. But as of right now, I'm going to put it under the over here between the last fake and the first like useful one. Okay, so I'm just going to say implicit. Let's actually make it private because it's in the companion object, so it's going to be visible anyway. Implicit val parse string to a unit, which is going to be a parse string into a unit. It's going to be a simple function that is going to ignore the input and will always produce the right of unit. Okay, like this, right? Great. And our test fails for the same not implemented error thing, right? And what's happening is exactly the same thing. Something inside of the controller is doing like override val. For example, over here, if we do like override def, maybe this will even be enough, but maybe there are actually more vals in there. Okay, so let's see. Override val. No. Maybe there's a private val. Yeah, there's private val, right? See, there's like 15 of them. Okay, so we're just gonna go and we're gonna maybe not all of them. Let's go this one. This one is good. This one good. Yes. Okay, so these ones, for example, they can stay as private vals. Okay, but these ones are going to become private defs. Okay. Great. Let's see if this is enough. And I made some mistake. I think I already know vector. There's some backslash n missing probably. Vector was not equal to vector. Let's see. Until next time. This looks correct to me. The T. This is a capital T. Okay, until next time. All right. There we go. Great. Yay, it's green. Okay, so now we can finally write an interesting test. Okay, this test was boring. Okay, so it's gonna look very much the same as all the others, right? They will always just create the boundary, and they will simply call assert. Okay, so I'm just gonna copy paste it, and this one will simply say, okay, it's gonna say should create on C, like this. Okay, and so what we're going to do is the input is going to be list of, so first it's going to be C, then it's going to be the to do, we used to say buy milk, but now for fun we're going to say invent time travel, and the date is going to be 1955 November 5th. Let's put it like at 6 o'clock, like this. Okay, and if we do this, then we expect the output of vector of successfully created the new to do. Okay, remember, like the real output is going to have colors. This one is not going to have colors because in the useful console over here, we said that success is simply going to be a regular put string line. Okay, now it says that we need an implementation, and this is why we have the fake boundary, so that we can actually insert some implementation. So we're going to go into create one like this. Well, not like this, actually, into, yes, override create one like this, and all we need to do is we need to say f pure to do existing, and we're going to pretend as if we created it. Creation means that we just assigned it some ID, right? Some ID of unit. Okay, so some ID of unit and to do like this. Okay, so assuming that we created it, we should see exactly this output. Okay, so look again, like, because we're using the fake boundary, we don't care about the logic, we don't care about the fact that it's actually saved into the database, we don't care about the fact that the description is going to be trimmed or something like this, right? We simply care about the fact that something inside of the controller would parse this date properly, that it would actually give us this output, right? This is all we need, and we can write this test even before we had the boundary. And yeah, this is all we need for this test. We're going to write a couple more. I'm going to say, and then this one is going to be, well, actually, again, I'm going to copy paste this one. Okay, paste it over here. I believe that this is the last one that we're going to write, and we're going to say should keep running on error. This is actually a bug that we're going to fix. Okay, because what's happening is that in in the HTTP layer, remember, if we had some weird errors, then something inside of HTTP would catch it, and then would just return the internal server error, the 500 to the user. In the regular, console application, we actually don't have that, so we have a bug. So we need to go and add something. And this is going to be our boundary. Let's for now not override anything like this. Well, actually, let's actually override something, right? So instead of this, right, instead of f pure, we're going to say raise error. Okay, we're going to say raise error. I'm going to say new runtime exception of boom. Okay. So we're going to do this, we're going to do that. Okay, so let's actually generate the description in this case. So we're going to do a for all description. Okay, put this guy in here. So now we have this description. Okay, and now instead of this, right, so this is going to be vector.empty. Okay, we're going to have expected errors. It's going to be a vector of boom. This is going to be a string, description of string. Okay, like this. Let's see. All right, what is happening? Runtime exception was thrown during property evaluation. Yes. Message boom, passing generated values. Okay, so basically nothing in the controller actually catches this exception. Okay, so what we need to do is we need to go into the controller, and we need to say that whatever is happening, and for this we're going to use Scala util control non-fatal. Okay, so we're going to go and we're going to say that we're going to use a monad arrow over here. Over here was a throwable. Okay, and now we're going to find our menu, which is over here, right? This whole thing. Remember, it flat maps, and then it's it returns a true. Over here, after like whatever's happening over here, we need to make sure that we're going to handle the error. And we had, like in the previous video, we had a big conversation about this, right? So, how we can forget to handle business errors. But in this particular case, this is not even a business error, okay? All we need to do is we need to console put error line, throwable, get message, okay? And then we need to make sure that it's going to keep going. So this whole thing is going to return true, okay? So whatever is going to happen, the application is still going to be fine, right? Because before, the exception was thrown over here in the useful console, over here, right? So basically it threw an exception, but it was asking for the next input or something like this. All right, so we're almost done. We're just going to write one more test. One more test. Let's go and grab this one over here. Just gonna grab it over here, and we're gonna call it. Okay, I'm gonna call it should yield an error if deadline does not match the required format. Okay, so we're gonna have the regular fake boundary, right? And this is, again, this is one of the beauties, right? So in this particular case, the boundary is not even going to be called, right? This is pure logic of the controller. So we're gonna generate some description over here, and we're gonna just generate some deadline over here, right? So whatever string is going to be generated, the chances are almost 100% that it's not going to be this, you know, like in this format. Okay, so we're just gonna stick it in here, deadline. Okay, and we're going to expect that we're going to see an error, and the error is going to be, it's actually going to be very long, so I'm going to copy paste it. Okay, because there are ANSI codes in there and stuff, so we're just going to do this. Okay, so it's going to expect that we have let's have it over here, import Scala console for the ANSI codes. Okay, so it's going to say deadline does not match the required format. Okay, and over here we're going to see a teeny tiny bug. And this is a reminder, always write your tests first. Always write them before you run the production code. Okay, so there's basically this ANSI code, this reset, it is inserted twice. Okay, so if I search for this, we're going to see that we're calling this guy, and this guy inserts a reset ANSI code, and then when it comes back, we're inserting one more, but we actually don't need to, right? So it's like this, and then our test is going to be green. If I jump over here, you're going to see that it actually always calls in color, and in color adds this reset code. Okay, and there we go. We have a couple of tests. All right, so let's actually run all of them. So as of right now, we have the tests, and remember they're being run in reverse. So let's run the the boundary first, the core first, then delivery, then persistence. So for some reason, we need to write them in the opposite order. Test, persistence, delivery, and core. This is the core, all green. This is the delivery, all green, and this is the in-memory gateway, all green. You can also do, if you just do this like btest to do, then it's not gonna do anything, I believe. Yeah, but if you do the same thing, and if you say include dependencies like this, then it's actually gonna find the tests and run them. And for the ones that it's not gonna find, it's just gonna display this warning. Okay, let's also run them through SBT real quick. We're just gonna do SBT. We have a type alias, and in the build over here we have the aggregate thing. We have this thing, aggregate all the projects, which means that if we give in a command, this command will be aggregated. It will be delegated to all of the sub projects, and this is what we're seeing over here. A bunch of things compiling and testing, and all in parallel concurrently, because we have like this fancy dependency graph, so it's really fast. It's really torturing all of my core. So let's actually run it again real quick, because like this one took like 28 seconds, to start SPT and then to actually run them. By the way, one more thing that I want to show you, because we're doing this SPT trick again. I might have shown this to you before. Somehow I just remembered it now. Over here in spt.spt, we're doing this turbo thing. Turbo, we're setting it to true, and what it allows us to do is, if we go inside of SPT, that it will cache the compilation, right? So we're not talking about the incremental compilation. Let me show you what I mean. So once it's gonna get started, I'm gonna press Control L to clear the screen like this. I'm gonna clean the project, and I'm going to say please compile everything, right? Compile the production code and compile the test. Okay, and it should take about 20 seconds maybe. Let's see. All right, so it took 19 seconds. Look what I'm going to do now. Because this is not incremental. Incremental compilation is like this, right? It's going to notice that everything is compiled. But I'm going to clean again, and I'm going to compile everything again. And now this time should go from 19 seconds to half. I'm going to say it's going to be 9 or maybe 10 seconds. Come on, 8 seconds, right? This is really great. So I highly recommend that you give this setting a try, and only if you have some issues, then remove it. Okay. All right, so this is great. Let me see what we changed so we can commit it. So I added the test suite. right? And we added this arbitrary again. Please don't add them over here, because like one of the problems, I believe I actually forgot to mention this, is that if you add this over here, a teeny tiny change to this will actually cause a recompilation. Actually, let me show this to you. Okay, we're compiling everything. Okay, so let's say that, I don't know, somewhere at the bottom of the file, I'm going to say print line hi. Okay, now it's going to cause the recompilation. Like in this particular case, you know, SPT was smart to notice that nothing at the bottom changed. But if your project was actually much bigger, you know, something would have you know, triggered like more recompilations. Let me try something else. Import Scala util chaining, because maybe this one would trigger more. No, it doesn't. Okay, well, okay. In any case, always pay attention to your compilation when you're dealing with implicits, when you add them to some like global traits or something like this. Okay, so we did this boundary. We just changed all the vals to DAFs. Boundary suite, wrote the tests. Controller, we just have like this non-fatal thing, and we handling the errors over here. All the defs changed to all the vals changed to defs. Where we fixed a couple of small things. ControllerSuite, this is probably the largest one. It's like 200 lines. In-memory entity gateway, just make sure that we're throwing something sometimes in the statement. We're making sure that we're handling the situation over here. In-memory entity gateway suite, we added a couple of tests. Build SPT. We just this is just a refactoring. Made sure that the domain has a dependency on util. Remove the dependency on util from this delivery guys, because now everything has it, and we have this. All right, great. So now let's go and commit this thing. So I'm gonna say last video. Yeah, this series is pretty much over. All right, let's push it. Let's go and see the changes and have a tiny conversation about everything that we have learned. All right, so I'm going to go over here, refresh, and this is going to be the last video. All right, so this is the test suite in all its glory. Was this arbitrary? Vals changed to defs, boundary suite, controller, just a couple of changes. Right, and this is exactly why you should always write the tests first, right? So ideally, you know, they should all have been green, right? It's a simple application. You know, we have a strongly type technique like Tagless Final. You know, we were very careful, and still issues all over the place. Small issues, but still, you know, unnecessary. All right. Great, so let me minimize that. Okay, so first of all, I'm sorry that the series was so long. Before I go, I just need to mention a couple of things. Well, I want to mention a couple of things. The first thing that I would like to mention is that we could have written integration tests. I simply didn't write them because, you know, just for time reasons, okay? Now, you can write them yourself because our application is cut so properly. You actually know exactly where to put them. For example, let's say you wanted to write the integration test of the boundary and the in-memory entity gateway. There's pretty much, well, because it's a large dependency graph, there's always like the first place where you can put it and everything underneath, obviously, right? But you should obviously put it in the first place. And the first place that you see it would be here. Right? If you wanted to do this in core, you know, you wouldn't even see the in-memory entity gateway. You don't even have like cats effect on the class path and all of these things. Okay, so you would go over here and you would write them, write these tests over here, right? So over here we tested only the in-memory entity gateway suite, right? But the real boundary is actually visible, right? So you can do boundary.dsl, right? So the object is visible, you know, because persistence obviously has a dependency on core. Same as in the controller suite, you know, you could have used like the real business logic, but you wouldn't have access to the database, right? Because it's completely separate, okay? And obviously in the main over here, you would have access to both of them, right? And you could write a test that does like everything, you know, was the real production, everything, except for maybe the console. The console would be probably the only thing that you would fake, and you would fake it pretty much exactly the same way. In fact, over there, if we actually go into the dependency graph for this one, okay, notice that you would probably fake only this console, all right? You're not even faking the fancy console because you can't inject it over here, okay? Well, you could obviously, right? But you would basically you would literally like call this thing and it would construct this whole thing for you. You would just give it the fake console. The second thing that I want to sort of mention, and it doesn't have anything to do with Tagless Final, but it does have something to do with functional programming, is thread pools. I tried to avoid to talk about talking about concurrency in this entire playlist because this entire playlist is already complicated enough. However, it's hard to not mention thread pools at all. So if we go to one of our mains, probably let's go to the one was the HTTP and then Postgres. In functional programming in CATS, there is this notion of context shift. Now, when you're dealing with something like futures, futures are written with fairness in mind, which means that every time you map or flat map, you actually might run on an entirely different thread. Now, in functional programming, you do this all the time. You flat map the entire application. The entire application is this one big, one big IO monad or something like this, right? So you have a bunch of flat maps, and so you would spend way too much time context switching. And so this approach that that's something like that your effect type is going to automatically just jump from one thread to another is not going to work. And so what you do is you do the same thing that people do in racing. Nobody races with automatic shifts. You race with a manual shift, and so you're being given this context shift. And so on your IO, you can call like .shift when you have something that you want to be executed on a different thread. In fact, even on a different thread pool. Okay, and then you can shift, and then you can also join back, right? So you can have like a fork join. Now, in this particular case, we didn't really care about this because A, this is a toy application, and B, it's written on top of HTTP4S, which is written on top of FS2, which is very asynchronous, and it's all fine and dandy. And also we used Skunk, which is not written on top of JDBC like Doobie is. Skunk is actually written, it's like a native driver to Postgres, and so it is also asynchronous. And so we could actually run the whole thing on the same thread pool because, as you can see, we're running HTTP4S, for example, on this thread pool, right? And when we're shifting the context, we're going to shift it to exactly the same thread pool, so we're technically not shifting anything. However, again, this is a toy application, and everything that we used so far was asynchronous, so non-blocking and all of these things. So we wouldn't have a block like the current thread. So it's all good. I'm going to leave a couple of links down in the description about what I just said. But basically, all you need to know that there are basically three kind of thread pools. The first one is that you use for the CPU bound tasks, right? So something like really crunching numbers, and then this is basically just a fixed thread pool with the number of threads that exactly matches your CPU cores, not even hyperthreads, your CPU cores. Okay, it's a fixed thread pools, and basically, by the way, the way thread pools work is that they pre-allocate the threads, right? The threads always live there, and then when you schedule the tasks, they're being just thrown at the threads that are already there. Okay, so this is going to be the CPU thread. Then the other one is going to be the sort of like the regular one that you use like simply for messaging, right? So for your application basically talking to itself, right, to go through all of the layers. And this is the thread pool where you don't wanna stay. Right. So as soon as you need to do something like even slightly remotely heavy, you need to offload it to another thread pool, which is going to be the last thread pool, which is going to be the one that is usually a wrapper around JDBC or a wrapper around something that is blocking. And this thread pool is not allowed to have a fixed number of threads because every time you block, a new thread needs to be able to be allocated, right? And then eventually you're gonna run out of threads, but at least you have some buffer. Okay. So anytime you need something heavy, you're gonna offload it to this pool, and it's you're gonna offload it to the CPU pool. Okay. In any case, I'm talking too much about threads. I actually didn't want to talk about this about them because this is supposed to be like just about Tagless Final. Okay, let me move on to the point number 3, which is futures. Now, even though futures match this this typical app with one slot shape, I highly discourage you from using futures for as your effect type because futures are eagerly evaluated, and so the chances are really high that they're going to introduce bugs into your application. So choose from one of the 3 effect types presented over here. In fact, in this file, and there might be actually more, but I believe 3 is enough to choose from. Which brings me to number 4. Which of these 3 should you choose? And I'm sorry, but I honestly don't know. I've actually never worked on a production Tagless Final application. So if you have performance or latency concerns, then please run your own benchmarks. My opinion is that they're pretty much like good for good enough. Like any of these effect types is good enough for the majority, like literally for 99.99% of the web application, unless you have some really crazy latency and performance concerns. So in this case, run your own benchmarks, and In fact, in this particular case, if you're so worried about this, and maybe you shouldn't even run on the JVM. Okay, if you have some crazy performance like this. Okay, apart from that, like there is some slight differences. For example, because we have flat mapping all the time, like a boss, these stack traces are being a little bit weird. You don't always see like everything in the stack trace, as I believe we have seen in this video. Like sometimes they weren't really unhelpful, or they were not even there. And Zio claims to have some fancy fiber dumps, and so Zio claims to have some better stack traces for you. Also, if you have seen my previous video about error handling, you have a choice between an F which has only one slot and an F which has two slots or three slots. And so if you're using this effect rotation instead of effect stacking, then you might get better performance. But again, like for 99.99% of the web applications, this really doesn't matter. Like mono transformers are usually being frowned upon because they're like slow and stuff, and they are, but they're not that slow that you're actually going to notice it. Like a teeny tiny index mismatch of your database is gonna kill your application much faster than micro optimizations like this. Number 5 is which not effect type, but which F should you choose? Do you want to choose like the single functor or the bifunctor or the trifunctor? And honestly, I don't know. It's probably a little bit harder to learn. The more parametricity you have, the harder it is to learn. But if this is not an issue, then I don't know. Just agree on something with your team and go from there. It's only going to get better with Scala 3, with the union types for the errors, also for the inference. So yeah, in general, like this is the recommendation that I can give you. Like whatever app you're using. Try to make them covariant, and this way you're gonna have better type inference in some cases. Let me just show this to you. So for example, over here, the boundary, just go and put a plus over here, right? You're gonna have like this, you're gonna have a better type inference. And number 6, which is my final, no pun intended, well actually yes, totally pun intended point, is software development is hard. And yet there seems to be a blog post pretty much every day which claims to have found some new and shiny way to develop software, new and shiny, silver bullet. Okay, everything we have been doing so far sucks. Now do this thing. Look, this series was about a super simple toy CRUD application. And even though we used an incredibly powerful programming language like Scala, even though we used an incredibly strongly typed technique like Tagless Final, we still somehow managed to introduce bugs. We still have somehow managed to have some weird APIs like this write many. Remember, instead of simple, create one, add one, we had like write many. Like when did we actually write many, right? The only time we did it was in our tests. So my point is that I highly recommend you to not listen to anyone who promises you silver bullets, especially even about things like Tagless Final. Like this is still like the new rage, and then like a lot of people in functional programming, they still write applications like this, and there's nothing wrong with it, right? But this is not a silver bullet. Okay, so please add these things to your toolbox. Use powerful programming languages. Use these techniques. Write your tests first. Don't argue about like types versus tests. You need everything. Add everything to your toolbox, and don't shove these things into anyone's throat. Okay. Now, I know that this got a little bit dramatic towards the end, but I really wanted to say this because every time like I read a blog post, this is what you should do now. It just drives me mad. Okay. And yeah, I hope you enjoyed this series. I see you in the next video. For now, as always, it's been Vlad, devinsideyou.com. Don't forget to like this video if you did. Subscribe if you want to improve the developer inside you. And if you learned something today or in this entire series, then consider supporting me on Patreon or on GitHub sponsors, whatever you prefer. And thus watch my videos weeks and sometimes even months before everyone else. For instance, I'm recording this video on 1st of September, but it's probably not going to be released until the end of October or even the beginning of November, but my patrons have seen it before. All right. In any case, most importantly, as always, take care.